hexagon.
Around this.
Yeah, so that was completed. Now let's move to the graphs.
Okay, I'll check which page. Give me a second.
469.
Wait, before we do the graphs, can we do the sine law first?
Sine law.
Yes.
Okay.
It's page 374.
Yeah. Okay. So basically, sine and cosine law are related to the relation between sides and angles of the triangle, right? So wait, I'll just share my screen. So firstly, we have sine law. So what happens is, for example, if I'm taking a triangle, any triangle, right? So let's take a triangle ABC. And if I'm drawing the height of it as, let's say, D, and the side in front of this is, let's say, X, Y, Z, and this is height, H. Okay. So let's apply sine. Okay. Let's do sine of A. What will it be? Sine of angle A. This part, this angle A we are taking. Sine theta is opposite over hypotenuse.
All right, sorry. I was confused by
sorry, my bad. Sine C. The sine angle B. This one. This one we are taking, okay?
Oh, okay. So it's BD.
What?
It's H divided by the X.
Correct. Now, this angle, sine C, what will it be?
Also the same, but height H over Y.
Yes. Now, from the first one, can we say that height is equal to X sine B? And here, height is equal to Y sine C, cross multiplying. Is this thing clear?
Yes.
Now, they both are heights. They're of the same length. That means right-hand sides of both of them are equal. So we can equate right-hand sides as well. Sorry, left-hand sides as well. So they were both H and H of the same triangle. So heights are equal. So left-hand sides will also be equal. From here, we can say sine B over Y is equal to sine C over X, dividing both sides by Y and then by X. Can we say so? That's all. So that was the first part. So as you can see, in front of angle B, we have Y side only. If I take triangle ABC, this is X, this is Y, this is Z. So in front of angle B, we have Y, and side will also be that one only. Similarly, in front of angle C, we have X, so it would be divided by that only. And similarly, we can equate it to the first angle only. If I take the height like this, so I'll get sine A over X equal to sine B over Y, and then I can equate all three, and this I get as sine rule. Sorry, this is Z. Okay, in front of sine A, we have Z.
Is that it? Is that like the sine rule?
Yes, this is the sine rule.
Okay. Yeah, it's a lot simpler when it's put this way.
Note this down. Ask if you have any questions, then I'll give you questions based on it.
Okay. Just give me a minute. Okay, done.
Okay, come to exercise 8.10.
Mm-hmm.
And yeah, question number 1. A, D, and G. Please try these three, A, D, and G. And question 2, we have C and F. These are the questions that we need to do. Are they doable, Sama?
Yes, they are.
Okay.
Hello. I'm on the last question, but I need to help with something real quick. Okay, I'll just do that and I'll finish the question and let you know. Okay, I won't take long.
Okay.
Okay, thank you. Hey, I've done everything except for the bearings questions. Hey, can you hear me?
Yes, I can hear you. Can you hear me?
Yes. I've done everything except for C part B for the bearings.
Which one?
Question 6, part B, the one for the bearings.
6 part B, 1 second. B from A. Oh, this is weird. 1 second, it's taking time to load. All others, please check it quickly, all others.
Oh, okay. Okay, I've checked them. They're all correct.
Okay. Coming to 8.106b, they're asking the diagram shows above 3 straight roads connecting points A, B, and C. The length of AB is 15. Calculate the length of the road BC. We can find the bearing of A from B is 290 degrees. Okay. Find the bearing from of B from A. Remember we did bearings?
Yes, I was just confused about the question. A from B, it's supposed to go clockwise from the north, but
Yeah.
when I see it, it looks like it's less than 180.
Less than 180. It's 290 from A to B.
Oh, sorry, I was looking at A. It's B. Yeah, from A. Yeah, it looks less than 180.
And from B to A, it's going to be. Okay, so this angle was what? This was 38. What?
38, 105, and 37.
37?
Mm-hmm.
Okay. From here to here. And this part is 37. And this part would be what? From north to A from B is 290. So this is going to be. I have to check this one. Bearing of B from C. From A. Okay, from B is given as 290. And so this would be 70. Yeah, done. No, see this B from A is given 290, right? This is B. Can you see the point? Wait, I'll just do it with red. Can you see this red point to here?
Yes.
This is 290, right? So the
Uh,
remaining would be 70. because the whole circle is
okay.
of 360 degrees. So if this is 70, this will be 70. Oh, sorry, this will be 110 because co-interior angles have sum as 180. That's all. That's what we wanted from A to B. This is A to B.
So
See.
for
Wait,
B
I'll
from
just...
C will be
What?
147. Would B part 2 be 147?
Yes.
Okay.
Let's move to sine rule, where we have possible values. In trigonometry, we discussed the quadrant summa, that in first quadrant, all the trigonometric functions are positive. In second one, only sine is positive. In the third one, tan is positive. And in the fourth one, cos is positive, right? Are we aware of it?
No.
Okay, so in the sine graph, when you draw the sine graph, what happens? I'll just show it to you. I'm drawing the sine graph. Can you see the sine x graph? This one? Yeah. Now, I'm zooming it in and you can see the pattern that it is a cycle which keeps on repeating. This is one cycle from 0 to 360 degrees. And where it cuts the x-axis is 180 degrees. So this is a sine graph, right? It completes one cycle at 360 degrees. This is one cycle. Now, as you can see, in first from 0 to 90 and from 90 to 180, the sine values are positive, isn't it? It's above the origin. Whereas in the third quadrant, this is third quadrant, 180 to 270 and 270 to 360, they have negative values. So that's what I was exactly talking about, the quadrants. In first one, for the sine, it's positive in only first and second quadrant, but in third and fourth, it is negative. For example, if I draw now cos graph. Okay, so the blue graph, it is positive. See where it is positive. It's positive in the first quadrant.
And in the second?
In second, it is negative. Were you saying something?
No, in the second it's positive, right?
Second is negative. It's below the y-axis, no? Below the origin.
Is the
Third is
second
also
the one
negative.
at the bottom or the one to the left?
This one.
Mm-hmm.
This is, if we are going to the right, we are going to the left, we are starting again from 4. This is the reverse. We are going from here to here. Okay.
Okay.
And for the tan graph, just focus on tan. Sorry. Now, even tan, if you observe the tan, from 0 to 90, it is positive. Okay. Then it will go from 90 to 180, it will go negative. 180 to 270, it will go positive again. And from 180 to, 270 to 360, it will be again positive. I'll just show it to you again. Here. So this is what we have to remember, keeping in the graphs in head. Sine and cos. So just make this graph, and why we have to use, where we have to use, let's understand.
Okay. Okay, done.
Now, when we are saying, for example, the angle that you are getting, for example, this is the case. This is given as, let's say 30 degree. This is given as 4. This is given as 5. Okay.
Mhm.
So how can we find this angle? Sorry, this angle. Angle A. So I'll use sine rule. Sine B over 4 is equal to sine A over 5. Okay.
Mhm.
So now whatever answer I'll get for B, that B can be they can be two values of B. Okay. So I'm putting the value sine B sine 30 over 4, sine A over 5, sine 30 is half, it will become 1 by 8 is equal to sine A by 5. Please check what is sine A using calculator. What is angle A?
$38.7.
38.7. That is in the first quadrant. First quadrant is from 0 to 90 degrees. Somewhere here is 38.7. So that is one of its value. You know that 5 by 8 is positive, and in the second quadrant, which is 90 to 180, there also it is positive. So what we are going to do now, we will be finding one value of this angle in second quadrant. How? Sine A can be sine 180 minus 37.7 also, because it's between 180 and 90, so it will be less than 180. And what we need to subtract this 38.7 that we have got. So it's going to be 180 minus 38.7, which is 141.3. This is another answer. This is our first answer. This is our second answer. These two are possible angles because we don't know what the third side is. We don't know what angle C is. So angle A can be two cases. Okay.
Okay.
And it is always in the second quadrant for sine. For sine rule, you have to remember the first value will be between 0 to 90 and the second value will be between 90 to 180 degrees.
Mhm.
Try this in 1 second. 8.11, question number 2.
Okay. It would either be 62.4 or 117.5.
Can you quickly, oh, 1 second. I'm checking, 1 minute. 117
5 or 62.4
Correct.
or 5.
Perfect. Let's move to cosine rule now.
Okay.
Yeah. So in cosine rule, Sama, we have again the relation between angles and the sides. So here, let's say we have a triangle ABC, and again the sides are X, Y, Z. Okay. Now we have a height here in between, and let's say this is D, AD. Now this is very important to understand. Let's take this triangle, the way we took in last time, triangle BABD. Okay. So if I apply Pythagoras theorem, I don't know what is this entire like BD and DCR. I just know that the entire thing is Z, right? So I'm taking this as P, and this will be Z minus P. Can we say that remaining portion?
Yes.
The whole thing is Z. If one part of it are taken as P, another part will be Z minus P. So in triangle APD, can we say x square is equal to h square plus p square using Pythagoras theorem?
Mm-hmm.
In this one, it will be y square equal to h square plus z minus p square.
Mm-hmm.
Now, again, we are finding the values of h the way we found in the previous sine rule. But here it will be h square. Now, as you can see, both 1 and 2 are h square equal to something. So we can, compare their x-axis, sorry, right-hand sides. Firstly, check it till here.
Could you briefly re-explain it?
Is which step?
The where you got x squared from.
This is Pythagoras theorem. In triangle ABD,
Oh, yeah, right. Okay.
hypotenuse square equal to perpendicular square plus base square, and same is for the other triangle. Now we are just comparing h square with h square. So this is what we get: x square minus p square equal to y square minus, I'm expanding this bracket, this is z square plus p square minus 2zp. This is a square plus b square minus 2ab. Now I'm expanding the whole bracket and changing the signs. Minus p square and minus p square on both the sides will be cancelled. So if you will observe it, x square minus y square plus z square equal to 2zp. Can we say that? I've taken y square and z square to the left, or we can write z later on. Sorry, z first and y second. I'll tell you why. And divide by 2z equal to p. Any doubts till here?
Yeah, the last, okay, z squared minus p squared, that's for h squared, and that means that y squared minus z squared plus p squared minus 2zp is just h.
1 second, 1 second. One second. Let's keep it till here only first. Oh yeah. Now please ask your question.
Okay, so if x squared minus p squared, that would give us h squared, right? So y squared minus z squared plus p squared minus 2zp, that's just all equal to h.
No, I think one mistake is there. Okay, we'll come to that. Yeah. So you're on this step? You were asking
no,
about
on
this?
the last.
Yeah.
Oh, yeah.
So you have to just expand the brackets and change the sign. So z square times negative is negative z square, negative p square plus 2zp. Should I repeat it?
Yes, please.
Is this step clear where we expanded this?
Not really.
A minus b whole square, a minus b times a minus b. That is what? A square minus ab plus b square. Minus ab will become minus 2ab. So a is z. I have written that as z square. B as p, which is plus p square, minus 2 times zp.
Okay.
It's just distribution property we are applying, okay? Then p square gets cancelled out both the sides, the same numbers. For example, if we have x plus 2 equal to 2 plus 3, so 2 and 2 we can cancel out. Now, x square equal to y square minus z square plus 2z. Now this p, this p we took it from our side. It wasn't there actually. So let's see how we can replace it with something. So I'm taking p. Let's take angle B. Can we say cos B will be adjacent, which is P, over hypotenuse, which is X? So can we say cos B is equal to P over X?
Yes.
So P can be written as X cos B. So I'm writing this P as X cos B over here. Replacing this P with X cos B. Now x square y square minus z square plus 2xz cos B. Now from here, what we can say, x square plus z square, I'm taking everything to the right hand side, minus y square equal to 2xz cos B. And from here, I can say cos B is equal to x square plus z square minus y square over 2xz. And that is our cosine formula. That's all. So just you have to remember this thing. We are taking angle B here and y square is only getting subtracted. If I have to find cos A, let's say, so it will be x square plus y square minus z square, because in front of A we have z, over 2xy. This is how it works. If I have to find cos C, y square plus z square, because x is in front of it, so minus x square over 2yz. That's all. These all are cosine formulas we have.
I think I'll have to go over them on my own to really
You can take a
understand them.
screenshot of it or you can note it down quickly. And yeah.
I'll take a screenshot because it is quite a bit of writing. Okay, done.
Yeah, so this is the first part. This is the second part. And here we have substituted the value of P, right? And this is the formulas that we can get, all three formulas.
Oh, okay.
Okay, so we'll be continuing this in the next next class. You can just, go through this and you can ask doubt in the next class, right?
Okay, I'll see you next week. Goodbye.
Bye-bye.